Right. Well, I think I'll get going. We've got a fair few people in already. So yeah, so this is a talk about how to build a Raspberry Pi robot arm and drive it with .NET 5, Blazor and SignalR. My name's Pete Gallagher. I'm a freelance software engineer. I've been doing this for years, mainly in the IoT space. I'm also a Microsoft certified trainer, an Azure MVP, a Pluralsight author, community meetup organizer, and I like to speak at events like this. I also obviously like to keep myself busy too. I'm also a STEM ambassador, and I do that mainly because I've got two young girls at home, and I want to make sure that they've got access to all of the necessary bits and bobs that they need to thrive as well. So yeah, it's quite close to my heart, that is. So today we're going to briefly talk about .NET 5 and then what's involved in installing .NET 5 on a Raspberry Pi. And then we'll spin up a couple of Hello World projects and then have a look at what the Raspberry Pi GPIO is. And then the first bit of circuitry that we've got in front of me down here that you'll see shortly. Then we'll look at how we can drive the GPIO using .NET 5. And then we'll go on a bit further and look at device bindings and how we drive servos and things like that. And then we'll briefly look at Blazor and SignalR before a couple of final demos and some Q&A. Obviously, do shout up if I'm not loud enough or if I'm going too fast, then by all means, just come off mute and shout at me. It's easier than me looking at the chat. I'm more than happy for you to just unmute yourself and chime in when you like. So .NET 5, this allows us to target pretty much any platform we like now, which is great. So desktop, web, AI, gaming, and IoT, which is nice for us. We also get the fact that it's open source and cross-platform, including the Raspberry Pi. And we get access to the nice new C# 9 features like records and init-only properties where we can go from something like that down to 2 lines now, which is nice. And pattern matching on types, which is pretty cool. And top-level programs where we have a Hello World that doesn't take many lines to begin with, but that gets dropped down to just 2 lines, which is that's great not only for demos like this, but also for people that are just picking the language up for the first time. We also get some extra features like system.text.json. So there's a new JSON implementation, which makes poor old James Newton King a little bit sad. We're not using his library anymore. Just to give you an idea of where .NET Core is, I don't have the data for .NET 5, sadly, but at the last count over in Build 2020, then there was more than 1.5 million active .NET Core developers in Visual Studio alone. So they're the easiest metrics, that file new project, they're able to track that when you've got that turned on. The other stat that I like specifically from this is at the other side, where 40% of new .NET developers are students. So that's really cool to see that .NET is filtering its way into the education system, where normally things like Python and C and that sort of language would be prevalent there. So I think that's quite important that students are going to then drive that forwards for us. You can catch up a bit more on that particular video there on YouTube, so do go and watch that later. I'll be sharing the slides at the end as well, so don't worry too much about noting things down. So getting .NET onto a Raspberry Pi is historically relatively complicated. It's not, if you know exactly what you're doing, it's not too bad, but there are quite a few steps, and you're talking about modifying some stuff in Linux that you wouldn't normally be off modifying on a day-to-day basis. And I got bored of doing that on a brand new Raspberry Pi every time. So I created a single line install script, which just makes life so much more simple. So that script there, you just run that one line and it will just, like that GIF is showing you, just install .NET 5 on your Raspberry Pi. And if you've got a Raspberry Pi 4, like I'll be demoing here, then the process only takes a minute or 2 and you're done. You just need to reboot your Pi and off you go. Then you've got .NET installed. So I'll go into the first demo and just show us how that is actually functioning on our machine here. So I've dialed in with PuTTY using an SSH session here. And again, make sure that you can read the text and stuff. But if I do a .NET -- info here, then we've got version 5.0.102 of .NET 5 on the Pi here. And that's where you'll be after you've run that line and rebooted your Pi. So I've also done a .NET new console. And I mean, if you've used .NET Core or .NET 5 already, then the CLI is a great place to spin up new apps. It's very fast compared to the file new project way in Visual Studio. And that's what I've done here. So there's some code here. There's not much to it. It literally just spits out hello world onto the console. And this is, I mean, obviously, if this is your first go at putting .NET 5 on the Pi, then this is definitely the place to start, because this is going to prove that you can build and run that .NET 5 application. So if I do a .NET run, and we'll be doing .NET run quite a few times, then this isn't going to be as fast as your multi-core PC. It just can't be. But a Raspberry Pi itself isn't too bad, really. A Raspberry Pi 4 specifically works quite well. And so we can see down there that we've got that hello world popped up, and we now are happy that we can build and run .NET applications. So that's all good.
Quick question. I assume there's no IDE on the Raspberry Pi. So
actually, go on. No, go on. Yep.
No, I was going to say, are you running anything from the command line then?
Yes, there is an IDE. You can build VS Code for the Raspberry Pi now.
Oh, wow.
So you can absolutely do that. But I'll show you right at the very end why you don't need to do that, actually. Okay. But that's a really good call out. And you kind of, spoiler alert, that is. But yeah, so I'm running all of this just with an SSH session. Which means, yeah, this is all running on the Pi, but yeah, I've got the interface on this side. Equally, you could use VNC, which you'll also see later, and a command line there, but that's even slower. So this works quite well for console applications. So not bad. So let's flick back to the slides, and we can talk briefly about the Raspberry Pi GPIO. GPIO, if you don't know, that stands for General Purpose Input Output. And it's not only things to be able to drive LEDs and read buttons, we also get serial interfaces like SPI and I2C, and nicely for us, we get PWM, pulse width modulation, which I'll talk a little bit more about later. To drive the GPIO in .NET 5, .NET Core as well, there's a NuGet package, the system.device.gpio NuGet package, and it supports Raspberry Pi and also a few other boards as well, but I'm a Raspberry Pi guy, so I tend to just stick to that. It also supports Windows 10 IoT, but I don't tend to look at Windows 10 IoT anymore. I don't know if anybody's used that. And it was great at the time, but it seems to be falling out of support. So with .NET 5 being able to run natively on Linux now, and then a few other things I'll get to later, I don't see the need for Windows 10 IoT really anymore. As Jason just pointed out, you can install this with the CLI just like I did. Or you could use Visual Studio if you were brave enough and use the NuGet Package Manager that way. I won't be doing that. I'm going to stick to VS Code. So this is what the GPIO kind of looks like on a Raspberry Pi. So you've got a whole heap of pins down one side. On those pins, you get things like power and ground and serial ports, PWM ports, and basic I/O. And each of those pins is numbered, where you've got pin number 1 and that square pin on the far top left-hand corner, and then across from it 2, and then below 3 and 4. But there are actually 2 different numbering schemes. Those numbers I was calling out there were called the board numbering scheme for obvious reasons, because that is the numbers on the pins on the board. But there's also this BCM numbering scheme, and that's referring to the chip that drives the GPIO on the Pi. I don't tend to use the BCM numbering scheme because now I've got to convert from that BCM number back onto the pin numbers, and it's just a waste of time. So I tend to just stick to that board numbering scheme. I've got a basic circuit that you'll actually see through a camera if everything works correctly in a moment, but I've got a button and an LED and a resistor. So this is essentially hello world components for any IoT application. And if any of you have got started recently, this is most likely one of the first things that you'll hook up. And actually, to get to that point where you're flashing an LED and a button is if you're just starting out, and even I quite enjoy it now on a new piece of tech, there's nearly always either something, wire up an LED, or there's a built-in LED somewhere that you can flash, and you know that you're on the way then. So the circuit I've got wired up, I've got pin 10 connected through a resistor to an LED. You need the resistor, otherwise you're going to draw too much current out of the Pi's pin. So something like a 220 ohm resistor will do that for you. It's fine. Then the other side's connected down to ground. Then on pin 26, I've got one side of a button, and the other side of that's connected down to ground. So it's relatively straightforward circuit. It's not particularly difficult, and you can just plug the wires in and the components into a tiny little breadboard, and you're talking pennies almost, less than £1 for what you can see on there, Pi aside, obviously. So let's make sure that we can drive that LED and read a button. So as I mentioned right at the start, I'm not going to write any of this code. I'll save live coding for Twitch. But I can switch between branches. So I've got a branch for each of these different steps we're going to go through. As somebody mentioned there that there's a GitHub repo for that, and quite rightly. And you can either follow the workshop and get to these points, or you can literally just switch between the branches yourself and explore how the code's working. So I'm going to switch to flashing some LEDs. And if I flick to my CS proj file, then we can see here now that we're bringing in the system.device.gpio library, that package, which is going to give us the control of the GPIO pins. And then in our program, we've now got some extra lines of code in there. We're bringing in a couple of usings here. So there's obviously the system.device.gpio we're going to need. I'm also bringing in system.threading, because what I'm going to do is flash the LED. So it's going to turn from on to off to on to off. And I just need a delay in between that. So that's why I brought that in. The first line in here is that same hello world console.write line that we had originally. And I leave that in my IoT applications, or a version of that, so that if I've got an application that, say, just waits for a button before the LED flashes, I don't know it's actually started running until I see that hello world popping up. So it's just a little visual cue in the console to show you that, yeah, you're ready. You can start now. The next part we do is we create a controller object here, a GPIO controller, and this is the part that's going to do the heavy lifting of most of our applications. And you can see here that we're passing in that pin numbering scheme of board that I mentioned earlier. Again, you could pass in BCM if you wanted to, but yeah, I'm not going to do that counting. Next up, we've got a couple of variables, just so that we can, if we wanted to change the pin, it's okay. But we're passing in 10 for that pin number. And if we have a look at the circuit, if you remember, that's where the LED was connected on pin 10. And then we've got this 300 that we're storing in light time. That's a value in milliseconds that we're going to use for the thread.sleep down below, just to inject that delay. Then a little bit further down, we've got a while loop, and we're literally just going to send a high value to our pin, which will turn that LED on. And then we'll wait for that 300 milliseconds, send a low value, and then wait for another 300 milliseconds. So that loop will just sit there turning the LED on and off. And then we're going to close the pin right at the very end, because that's good practice. Release the resources. So let's see how that runs. So I'm going to run this, in fact, just up and enter. And I've got a camera pointed at my rig, and I can zoom in to where the LED is. And all being well, if everything works correctly, then we have a flashing LED. So, I mean, actually, that's good. That's the first demo that's actually worked. So that relaxes me a little bit. What can happen is that you over practice, and then you leave something like this running and you forget, and then you try and run another one and it says, I'm not doing it because I'm already running somewhere else. And yeah, I've done that, and it's quite embarrassing. You might also see that it looks like the LED's flashing in a strange pattern. It isn't. What I've got here is I've got my phone pointed at this rig, and I've got a little piece of software on the phone that's broadcasting the camera, and then this browser is picking up that broadcasted camera. So, and it every now and again it'll flash and it'll do some funny things, but it is actually flashing a nice regular pattern. It's just that this strange rig that I've got. Really, what I should do is buy another decent webcam. That would be the way to go. So what we've done now is we've proven that we can drive the GPIO, but you remember from the circuit, we've also got a button. So let's make sure that we can read the button. So let's switch to another branch of code where we read a button, and then we just wait a second and let that thing catch up. It takes it a second just to switch branches for some reason. Do it. And there we go. So everything at the top, all up here, is pretty much exactly the same. I've not changed anything. And we're still spinning up a GPIO controller and passing in board. We're still specifying our LED pin, but we've now got a button pin on 26, which matches the circuit that I've drawn out there. So what you can see, though, on this rudimentary circuit diagram is that it just goes straight into the pin. Now, if you know anything at all about electronics, often you'll find that you'd need to pull that button pin some way, either high or low. And it's really going to depend on your application of your circuit. But I've not done that, because what you can actually do is when you specify to open that pin, and I'm going to open it as an input, but an input pull-up. So internally within the Pi is a little tiny resistor, and it's going to pull that pin high normally. And then when I press the button, it's going to pull it low. So the logic in my program is going to seem a bit backwards. So I'll show you that. So I've got the same while loop I had before, and what I'm doing is reading the button pin, and if the button pin returns a false, so it's low, a 0, then I turn the LED on. So it seems a bit backwards, but pressing the button will illuminate the LED, and then not pressing it won't. It'll just turn the LED off, and then I'm closing a pin again. So let's see if that works. So the first thing we'll see is that LED should turn itself off when it's finished building. Yep. And now, if I press the button, I get an illuminated LED, and you just have to wait a second for my screen to catch up there, but that is the LED turning off and on when I press the button. So that's actually the most complicated way you could possibly connect a button to an LED with a 40 quid Raspberry Pi in the middle of it. But what we've done is we've managed to prove that we can read and write those GPIO pins. And then you're rocking and rolling at that point. The world's your oyster almost. So that's the end of the demo and we're finished. No, I'm kidding. What we need to look at next is something called the IoT device bindings, because just driving an LED and reading a button is not very interesting. But nicely, somebody else has written a whole heap of code that will allow us to be able to integrate peripherals into our application without having to worry about the lower level code that you'll need to write to do that. So it's something called the IoT.device.bindings NuGet package. And what it does is give you a whole heap of code for things like temperature and humidity sensors and I/O expanders and Explorer hats and Sense hats. If you've not seen what a Sense hat is, then I'm holding it up to the camera there. You should be able to see me. This little device has got a bunch of LEDs make a rudimentary display and a couple of buttons and a temperature sensor and a humidity sensor and a magnetometer and a gyroscope. Really powerful little board. But what's cool about it is that Tim Peake took 2 of these and Raspberry Pis up to the space station, and students, young adults and children can write experiments that run on the space station and they get those results back. That's really cool. I really like that. And that doesn't speak directly to what we're doing because they'll write all of their experiments in Python. But what somebody's done is written the .NET code for this. So what's great about this board is it's all those little extra components that are already wired up for you. And you just plug this on to the top of your Raspberry Pi, and then somebody else has written the code for you to be able to read those things. So it's a really great thing to get you into IoT. Just buy one board, plug it in, and you're off. Luckily for us, somebody has also written some servo control code, and I'll come on to servos just shortly. We've got our robot arm that you caught a glimpse of there when I was showing you the demonstration there, all wired up. So at the top of the Pi here, I've got something called a Servo 6 board. Now, ideally, you can't plug your servos, and servos are little motors, if you will, with a range of motion. You can't plug them directly into the Pi because they could possibly take like a couple of 100 milliamps, and a Pi pin is only really rated at 30 milliamps. So this Servo 6 board allows you to be able to plug in a battery pack into one side and just the control lines for the servos into the other, and that means that the power comes from the battery pack and not from the Pi. And it just safeguards all the pins on your Pi. It might look like it works for a bit, but then it might be that you're trying it the next day and it's not working at all. So yeah, I highly recommend something like this. There are I2C or SPI boards out there that will drive servos and PWM stuff as well. But this board I like, it just works. So you can see at the top here, I've got a bunch of wires connected. The first one is the ground pin. Now, if you were to buy this particular board, and in my GitHub repository, there's a link to one of the online stores for you to have a look and buy that. Then when you pick it up, the numbering system it threw me the first time I looked at it. You can see ground is written near the hole on the right-hand side, and it took me a while to spot that was actually ground. And then you can see then at the top that we got channel CH and then 1 to 6, and they line up with the pins. So I've connected ground there from pin 25 on the Pi. Next, I've got pin 35 and pin 13 connected. Now, these are the 2 hardware PWM ports. Pulse width modulation is PWM, and I'll show you something about that in a minute. Now, the Pi's only got 2 hardware PWM ports, and the servo control code really relies on the hardware PWM. There is a software PWM implementation, but it doesn't work very well with the servo code at all. And I'll show you why at the end of the talk. But for my own purposes, I've even connected a pin to demonstrate that. But I'll just show you a video of what it actually does. Then on the other side of the Servo 6 board, we connect our servos. And this far left pin, it's either going to be on the servo, it's either going to be yellow or orange, and that's the control pin. That's kind of the most important pin. And that's the one that we're going to use to move the servo around. And then we have the power and the ground. The ground is either going to be black or brown, just depends on which servo you buy. So that's good. So I knocked this up last night and added it to my slide deck, actually, because I was actually explaining how PWM works with my hands, and it's far better to do it visually. So this is kind of rudimentarily what a servo will look like. So the main servo block, and then the green part is going to be the arm part that's going to move. Now, what you do on the control line, that yellow or orange line that you can see, is you send pulses. Now, if you send a pulse that's quite short, that'll move the servo down towards 0 degrees. And if you send sort of a pulse that's twice as long as that, then it'll settle there about 90 degrees. And then if you send a pulse that's twice as long as that again, then you'll probably get to about 180. Now, these figures are arbitrary, just for demonstration purposes, but that's the idea of PWM. And I just enjoyed, making the PowerPoint animation for that more than anything, actually. But that aside, let's prove to ourselves that my batteries haven't run out and the servos actually work. So if I go back to here now, I have to remember to stop this code because otherwise that's going to cause problems. So stop that. And then I'm going to switch now to the move servos branch. And then we just have to wait for that to update. There we go. So that's finished doing that. Now, if it's CS proj file, you see that I brought in this iot.device.bindings NuGet package. And again, you can either just type it in here if you want, or you can just use the .NET CLI to do that .NET add package iot.device.bindings. It's worth pointing out when you do use the CLI, it is case sensitive. You are going to need to make sure you get the capitals in the right places, which is hard for me because I want to capitalize that T. So that's relatively straightforward. In here now, I've brought in a couple of extra usings. So I've got the PWM and I've got the servo motor. You can see the PWM itself is coming from the system.device. So we could do away with the IoT device bindings if we knew exactly how to use PWM to control our servo. But that's more complicated than it needs to be. Certainly when somebody else has written this iot.device.servo motor section of code for us. Down here, we're still doing Hello World because I like that. But the next thing we do is we create a PWM channel. And this is what we're going to pass into the servo motor control. Now, creating a PWM channel takes 3 different parameters. The first one is a chip number. And as I mentioned earlier, we've got hardware PWM on the Pi. And that we've got one chip in the Pi that's got 2 channels. So we've only really got one chip. So that's why that's going to be 0 for both of them. And then you've got the channel number here. So we've got 0 for PWM channel 1 and 1 for PWM channel 2 because everything is 0 indexed. And then we've got a frequency that I just leave at 50 because it works. Just leave it alone. Next up, we create a servo motor and we pass in our PWM channel. And then we've got the maximum angle that you can set that PWM to. So ours are 180 degree PWMs, which is fine for a robot arm. But you can also get 360 degree PWMs. So that's what that's doing. Then we've got a minimum and a maximum pulse width. And those 2 things are related to those animations that I showed you on the previous screen. And it's really about how you set where that minimum and maximum actually is. And it could be that you need to fettle around with those a little bit, depending on the servo you buy. The servos I've bought are like 20p ones from Amazon. So I think the 9G servos or something like that they're called. So not particularly expensive. Which is, fine, and they just work. There are heavier lifting servos. If you're going to make a big, sturdy robot arm, then you might need slightly different servos. But after that, we create another one of those. So I've got 2 servos in this particular piece of code. And then we do this servo motor 1.start and servo motor 2.start. And that starts the servo controlling, the PWM lines controlling the servo. Then we've got our traditional while loop that we've got down here. and I've got these two servo motors that I'm controlling, and I'm passing in an angle. Now, I made just a little silly subroutine down here just so it tidies it up and makes the code progression work a little bit nicely a bit later. So I pass in a servo and an angle, and then I just call that servo.rightAngle, passing in the angle. So servo motor 1, we set to 70 degrees. Servo motor 2, we set to 20. Now, servo motor 1, when you see it, will be the pincers, and servo motor 2 will be the actual movement of the arm. And then we set servo motor 1, the pincers, to 150, and servo motor 2 to 50. And we put some delays of a couple of seconds in between each of those. So let's make sure that that runs. So let's do this and get this up. I'm going to zoom out and zoom into the pincers because they should be the first thing that moves if it all works and the batteries haven't run out. Yep, there we go. Oh, the batteries are running low. Yeah, but that's working. So I'm going to stop that before the batteries run out. I probably should have changed the batteries before I gave the demo away. But yeah, so that's basic servo control there. So we've got, at that point, control over our robot arm, but obviously we don't have any interactivity. We're not controlling that directly. It's just doing a little dance for us, which is fine, but not all that interesting. So let's talk about Blazor. If you don't know what Blazor is, it's a single-page app framework for building client-side web applications, but using C#. It was originally this guy, Steve Sanderson's pet project, and he demoed it at a conference, and a few Microsoft people saw it as, wow, we want this. It's absolutely fantastic. And what they liked about it is that you can code your client-side stuff in C# instead of JavaScript, which if you've got a bunch of C# devs, then you can just reuse that knowledge base then to create web apps, which is great, or reduce a team even potentially. It's very much like ASP.NET, so it's Razor sort of syntax and HTML. And there's two different varieties, two different flavors, if you like. There's server-side Blazor, and as the name suggests, that actually runs on the server. And there's a little thin client that runs on the browser, and the server side just passes changes to the page, DOM changes down to the page when they need to happen, and the page updates it. What's good about that is that if you don't want to have to put your software onto a client's machine, then you put it on this server side and it keeps it all locked away, which is great. The downside is if you lose network connection, the web page stops working and you can't use it. So there is something called client-side WebAssembly, and this is really, I think, where Microsoft are putting all their eggs. And that essentially lets you run a .NET virtual machine in the browser, and it passes down actual proper .NET standard DLLs down to your application that's running in the browser. So this is a proper .NET application running in the browser, and it's super fast as well. And there's speed improvements coming for that all the time. So this is what I'm going to be using as the client side. And in actual fact, I'm going to use something called hosted client-side WebAssembly, where I've got a server part and a client part. The server part is going to handle what's coming up next, which is SignalR. If you've ever seen any of my talks or follow me anywhere, you're probably just used to me doing IoT hubs or IoT Central or something like that when I'm talking about IoT applications. But I wanted to demonstrate sort of a real-time thing here. I mean, you can get it to work that way, but really, if you want that instantaneous response, then SignalR is great for that. So it adds real-time web functionality to applications. It was open sourced but created by these two clever guys, David Fowler and Damien Edwards, way back in 2011. So it's pretty old now, well bedded in. And it enables real-time bidirectional communications between applications. At the top level, it's going to support WebSockets, which is definitely the best way. But if you've got some network restrictions that stop that, it will automatically drop down to server-side events and long polling. There's more information about that. I'm not going to dig deep into how SignalR works. You can sort of see it, all being well, just here. So let's drive the arm. So there's going to be quite a few steps in this. So shout if I go too fast or say something that doesn't make sense. So the first thing I'm going to do is flick over to the web app. So I'm going to have a Blazor WebAssembly hosted web app running on my PC. and I'm going to let the Raspberry Pi dial into the server side part of that to connect to the SignalR hub. So it's going to be like a little piece of code that runs in the server, and the Raspberry Pi will connect to that, and also the client side part of the application will connect to that. And that's sort of how the communication route is going to work. If you've never seen a Blazor application, you can actually spin these up and run them from Visual Studio Code. So I've got this launch and debug standalone Blazor WebAssembly launch configuration. Now, if I press F5, it will build that in the background. And we just wait, and that's built. And now we get loading, and what that's doing at this moment in time is instantiating that little virtual machine, if you will, and sending down the .NET DLLs and the application and running it. And then we get a Blazor application. I've got this squished to the side, so it's gone into responsive mode, which is a good demo on its own because you get that baked into this vanilla app. And I really like this out-of-box experience for Blazor because it gives you just enough to be able to build off it. So we've got a home page and we've got a counter, and you can click the counter, and that's a bit more impressive when you're running the server side because you click that button and it goes up to the server, and then the server sends the change down. So this is just a replication of that, if you will. Excuse me. And then we've got a fetch data page, which is actually fetching data from that server side from a little API. So that I like that because it really does look nice and feel nice and gives you some options to start playing with. So I'm going to stop that and stop that from hosting. And what I'm going to do next is add some Blazor controls. So if I now flick across to the code view, we can actually see there's 3 separate sections to this web application. So there's client, server, and shared. And client is where your pages are. So if I go to the index, then I've got some code in there. And this is just HTML with what looks like Razor syntax in it. So that should be pretty similar for, if you've done any ASP.NET, this should look quite similar to that. This sort of idea is slightly different. But what this will do is bind the value of this slider to a property in the code behind, which I'll show you shortly. But the reason why I've done this intermediary step is I'm using something called Mat Blazor. And this is a free and open source set of Blazor controls. Really nice, actually. But I wanted a slider, and that's where it was. I could just grab it from this Mat Blazor. To use it, there's a couple of things you have to do. There's an imports.razor, and you need to import it at that point there so that it knows to drag in the libraries. And you also need the CSS and the JS, and you put those in this index within the root. And then there's another couple of things that you can do as well, but that's primarily what you need to do. So that all works nicely. So going back to the index.razor, I'm going to add the code to that now. So let's add the control code. This is also going to bring in the stuff for SignalR. So we already had this at the top. You might have seen it if you were eagle-eyed enough. So this is where we're pulling in SignalR client. And actually, a lot of this code is going to be quite similar here on the client side of the application to what's on the Raspberry Pi as well, because they're both performing a very similar action. It's just one's driving and one's listening, that's all. So there's those 2 sliders we had before, and they're linked up to servo 1 and servo 2. And there are 2 properties down here in the code behind. So we've got these 2 public properties, servo 1 and servo 2. And below them, I'm in this on initialized async, which is when the page is loaded. We're creating a hub connection. And we're looking for it on this URI, this chat hub URI. And that's on the server. So if I go to the server, there's a hubs folder here, which is by convention, and a chat hub within that. So in here, we've got a send message routine. Now, if you call into a SignalR hub and you pass that string of the name of the subroutine that you want to call into, so a little bit clunky, it feels, but it works quite well. So it finds that sent message just there, and it sends to all of the clients a receive message command, which I'll show you shortly on the Pi. There's a few things you need to do to get SignalR up and running. One is in startup.cs rather. We have some services. Don't worry too much about this. This is just so that you've seen it and you know where this stuff comes from. We add the SignalR service in there. And then down at the bottom down here, we add that chat hub endpoint, and we point that at that chat hub class that we had up here. So that's sort of the main part that you need to do for that. So that should be, if I go back up to our page up here, in that when we move that slider, it will automatically update this property, servo 1 and servo 2. And when it does that update, it will send this send message to the hub. And it sends it with two properties that I've defined here. Now, if you've ever done any SignalR, or when you do some SignalR for yourself, the demo application will be a chat hub, which is why this is all based off of that. And there's a user and a message, and that's kind of how this is working. So I've just taken that demo code and usurped it for my own purposes. So the user I'm sending is the servo that I want to control, and the message will be the value of this servo property between 0 and 180. And I'm doing that for both servos. And then there's a few bits at the bottom down here we don't need to worry too much about. So I'm going to spin this up and hope that works. It's going to take a little bit longer to build because this is no longer just a vanilla Blazor application. We've now got SignalR and stuff included. But it does give me a chance to have a drink. For some reason, it caches as well. So it shouldn't look like that. But if I refresh the page, then now we get our nice servo 1 and servo 2 sliders. But what I haven't done is start the Raspberry Pi side up. So I go back to the Raspberry Pi code and we switch to the relevant branch there and let that update itself. And there we are. So that's done. So I've left the vast majority of this code as it is actually, but I've added a couple of extra usings in here. So we've got threading.tasks because SignalR is async. So we'll need that threading.tasks for that. We'll bring in that same SignalR.client that you saw in the Blazor client application and system.net.http, which SignalR needs. We create this hub connection, and I've created it outside of the main task because we're going to use it. And then we're doing the same things here, console.writeLine, and creating our servo motors and bits and bobs. But below that, we're creating the connection, very similar to what we did in the client app, but we're going to pass in a URL to this one, and it's looking for my PC IP address, and this is the only part of coding that I need to do for this demo. So I happen to know that my PC, unless it's changed, is on that IP address 192.168.1.162, and it's going to be running on port 5001, and I'm going to dial into that same /chat hub. Now, one thing I've had to do is I've had to pass this configuration in, and I've had to tell it to accept any server certificate because I couldn't get it to trust the .NET certificates that were sitting on my PC. So for some reason, it was just revoking that the whole time. It was saying I'm not having it. Now I had a look on Twitter, and there was some information on there about clearing certificates and all that, and it just didn't work. So this is great for demos, but obviously don't do that in production. Figure out what the actual problem is. So once I've done all of that lot, then I can build that connection. And then down here, this is where we're receiving that message. So it's looking for that receive message, and it knows it's going to get a user in a message. And if the user is servo 1, then I'm calling my move to angle, and I'm telling it to use servo 1, and I'm just converting that message into an integer. And I'm doing the same for servo 2, and I'm also lining out the message and the user. So we can see actually on the screen what it's doing if nothing's happening. And if the batteries don't work, then that's what we'll be relying on. And then we just start that connection up. But if we just leave that and don't do anything else, the whole thing will just stop. So I've got a while loop down here that just sits there and does nothing at that point. And at the end, I just stop my servo motors. So let's see if that runs, shall we? I need to get two different windows open at the same time. You should get a little jolt when it starts. Assuming I've not, killed my batteries already. So that should have started. And if I now zoom in, all being well, yep, I can drag the sliders and open and close the pincers. So that's servo 1 opening and closing. And I can drag this one and then move the robot arm around by dragging that. So I like that. I was quite happy with that when I got it to that point. And I mean, I know it's relatively rudimentary, but there's quite a lot of pieces we've stitched together there. And this is robotics that we're doing with the Raspberry Pi. And we've been through the code, and although there's quite a lot of bits, as I say, it's not that hard to understand once it's broken down into those individual pieces. And obviously, again, the world's your oyster at this point. You can do what you like. And if you don't rely on just those two hardware PWM ports, and you have some I2C equivalent, I mean, or you do something with like a Raspberry Pi Pico maybe, which has got like 16 PWM ports on it, then you can have fun and do what you like. It's worth calling out, by the way, I'll provide a link to this particular servo arm, but Clifford Agius, who I see is actually in this session with me, himself and his son have created a way better version of this arm that is, because it took me about, I don't know, 5 hours to print this, and probably about an hour to put it together and trying to find bits of nuts and bolts and stuff. But the version that Cliff and his son have created, you just get the screws at the top of this, and you just about see them. You just use those screws and the servos to bolt this arm together. It's fantastic. And I think it only takes about 2 hours to print and about 15 minutes to put together if you take your time. So thanks very much to Cliff and his son for that. And the files for that are in the GitHub repo, and I'll show you a link for that too. So yeah, I like that. That's really good. And I'm going to close that window. I'm going to close that window. I'm going to even close this window. And I'm going to stop that servo and close this. I'm closing everything down just to make sure that I don't end up with problems. So if I flick back over to my slides, we do have time to talk about Uno. So if you've ever tried to do any graphical front-end work for Linux, then it's traditionally quite difficult. And for a while now, there's been some Xamarin work in the community to get that to work. But this company, Uno, they've actually created a universal Windows platform, UWP bridge, that will work not only on iOS and Android and Windows and Mac, but it'll also work nicely for us on Linux now as well. So it allows you to run your C# and XAML code actually on a Raspberry Pi. It's created by this clever guy, Jerome Laban, and it's open source and cross-platform. And the latest version of that was released at UnoConf recently, and that's version 3. And that exposes to us WinUI 3, but it also gives us this Linux capability. It uses under the hood something called Skia and GTK. If you've ever done any GUI work on Linux, GTK will be something you'll have heard about before. So I just wanted to quickly show you how that works. And I'm not going to dive too much into how the code's working, but I am going to show you quickly the fact that if I press this code here is on my PC. So I've cloned my own repo onto the PC. So this code isn't stored on the Pi anywhere. If I just press F5, and assuming I've got the right thing selected, then what it's going to do is going to build the code on my PC. And because of a bug with the Roslyn analyzers, it'll actually build it twice, annoyingly, but don't worry too much about that. And then once it's finished building it, it'll do something called a publish. And on a Windows, just the binaries that are compatible with Pi. And to say these funny little things on the side. But sometimes it works, sometimes it fails, but I'm still talking anyway. So yeah, rsync is traditionally a Linux application, but there's a version for Windows called CW rsync, and you open a little SSH tunnel across to the Raspberry Pi, and then it compares this directory with the one on the Raspberry Pi, and copies the files. And that
Pete, just going to jump in. Your audio is jumping around all over the place, mate. Just letting you know.
Yeah, Pete, it just started happening. I wasn't sure if it was just on my end.
Yeah, I think it's because I'm building. It'll probably stop itself in a second. It might be.
Yeah, I think you might have to repeat a bit because of precisely that.
Demoed it. For some reason.
Hey, Pete, we're still having choppy audio. Are you sure it's not maybe something that has to do with the Microsoft or any batteries or something like that? Or all right.
Oh, was it? Can you hear me?
I can hear you fine now, but let's
good,
see if you just.
That might be better now.
Is it finished?
Yeah, that should be done now. Yeah, so apologies for that. For some reason, that particular step, it doesn't like it. But what we've am I coming through loud and clear again now? Cool, that's all right. Apologies for that. Yeah, for some reason, when I run this every now and again, it slows the whole computer down. And if I get Task Manager up, then I get a whole heap of .NET host processes being spun up. So I think there's some issue with VS Code. But anyway, what I've got here now is I've still got my live feed to the robot arm, but on the right hand side, I've got a GUI application, an Uno application running on my Pi. So I've got VNC on the right hand side, and I'm just dialing in. There's some stuff that you need to do to get this to work, but I'm going to release a blog post explaining a lot of that soon. But if I drag these servos around, then we can open and close the pincers, and we can drag the robot arm around as well. So yeah, I was quite happy with that. It took quite a bit of doing to get that to work. So I mean, that's been launched from my PC, and it's launching a GUI application actually on the Pi. So that was a pretty cool step to get to that point. And essentially, that's the end of the demos for that, which is good because that one tends to break the PC. But back here again, it wasn't always as sort of straightforward as what you can see. Obviously, there's things go wrong. So I thought I'd show you a couple of those. When I was playing with it, my cat took a massive interest, and every time there's servos now, she comes dashing in. This is what happens if you try and use the software PWM. So it's really jittery, and I tried all the different settings. I couldn't get that to work. And also, you must make sure that you tighten your robot arm down, because otherwise you can accidentally do something that will end up with it on the floor. So yeah, do be careful. It could hurt somebody if that thing was big. So yeah, there's a whole heap of links here. And again, I'll be providing the slides. I'll upload those to SlideShare not long after this. I actually wanted to upload them before, but SlideShare seemed to be having a bit of a problem today. But I will give you the link to that. But the first link in there is about my workshop. So all of the GitHub repos there for you to be able to have a look at. There's a bit more information about C# and .NET 5. And if you want to learn just about GPIO and driving it with .NET 5 on the Pi, then I've got a blog post there. And then there's a bit more information about those two NuGet packages that we had, as well as there's the 3D printed robot arm I'm using. And here's the one I recommend you use by Cliff and his son there. So if you go ahead and go and do that, then all the files you need for that are there. A bit more information about Blazor and Map Blazor I mentioned. Awesome Blazor, if you want to get a bunch of really cool tutorials and open source bits and bobs for Blazor, then there's a little GitHub repo there, and it's got a heap of great stuff in there. And some more information on SignalR and Uno. Onwards from that, I run quite a few meetup groups, but one of them is Knots IoT, and we have some fantastic speakers. But this month coming up, or next month coming up rather, we've got Terence Eden talking about the connected house of horrors, and he's talking about all of the problems with all of the connected kit that you've got in your house. It's a really good talk. And then we've got Peter Shaw, and he's showing you how you can hack your USB gadgets with .NET, and that's really cool actually. He was showing me that as he was working on his talk. If you want to get serious about IoT, then myself and some Pluralsight authors are creating some Pluralsight courses to help you pass the AZ220 IoT developer exam. That's a really good way to level up your knowledge and give yourself a career step if IoT is where you want to go. So go and hit that link up. And in fact, I've got a whole heap of 30-day Pluralsight course codes. So if anybody wants those, then that will give you access to the full Pluralsight library for 30 days. Those 10-day trials that you have on Pluralsight only give you 3 hours worth of content. So mine are unlimited. So if you want those, just reach out either in the chat or on Twitter or whatever you like. That's that. If you want to contact me, then it's @Pete_codes. I really should have removed that underscore on that thing. That's definitely the best place to catch me. I tend to miss emails because there's just so much spam. But do come along to Nuts IoT or .NET Nuts as well, or Nuts Dev Workshop or Lati, or hear me on the Agile Engineering podcast, or I stream on Azure-ish Live. And these slides will be on that link there, that bit.ly PJG NDC 2020. And with that, I'm happy for everybody to come off mute if you want to and ask me questions, and tell me off if you think I'm doing something wrong or whatever. I'm open to any of that. I hope it was enjoyable and you liked it.
Yeah,
That was great.
it was really interesting.
Cool.
Pete, can you
go ahead.
put up the link again to your slides? Sorry, I missed that.
Yes, absolutely. Sorry. Yeah.
Thank
there
you.
you go.
Thank you.
Was that what you were expecting from this talk? Did it give you what you came in? Because obviously what we don't have now is the little leaflets, the red and green leaflets that people would be leaving at the door. So it's actually quite difficult to gauge whether or not people enjoyed the talks. I thought I'd just ask people, and I don't mind. I'd far rather people say, I wish you wouldn't have done X, Y, Z, or you've done X, Y, Z differently, because I can improve my talks that way. So obviously, if you do have any feedback, then I'm more than happy to receive that, constructive or otherwise.
I really like this talk. A lot of examples on how to do it, and you could squeeze in a cat. It's fantastic.
She does. She can be in another room entirely, and she'll come running in, and she'll jump up on the desk, and she'll sit, and then she keeps getting closer and closer to it, and she wants to do something with it, and you can see she's a little bit timid. But it's obviously a higher frequency than the one I can hear there that she likes. Yeah, I find it quite funny, so I thought I'd pass that on.
Actually, I have a question. So, I have a parts of Lego Mindstorms, and is it even possible to use this servo model from Lego with the Raspberry Pi?
I believe you can actually, and in fact, once you've got control over sort of servos, then yeah, there's a whole heap of stuff that you can do. I've not played with Lego Mindstorms, but I've seen it before, and it's fantastic. Has anybody else played with Lego Mindstorms? Cliff has. Have you got anything to say on that, Cliff? Cliff's also a fantastic IoT guy, by the way. So I definitely call that out. But
Yeah, I got it from my my two boys, but they were far too young, so they didn't enjoy it as much as I did. But it was a great toy for me. But yeah, it was fun, but it was a bit limiting. You're kind of stuck with just the Lego stuff. So I found that I was wanting things that weren't part of the kit, which then meant you had to spend a lot more money to get the things that you wanted.
yeah, I'm sure I saw somebody driving it on a Pi.
You can now. The version I got was some years ago. I think I got the V1. I think up to V2, V3 now. I think, aren't they? I think the Mindstorm stuff.
I don't
but
know.
yeah, it's quite a lot of stuff in there. It's quite a kind of active thing now to use. But yeah, as I say, my kids were a bit too young when I got it.
Yeah, it looks like the Magpie have got something on there as well. So, I mean, I'm guessing it's going to be USB, and because it's USB, it's probably just a virtual serial port that you just control this with. So once you know what the serial commands are, then you're off and running. But the fact that somebody's already done it there, then yeah, so just search on the internet and you'll see that in the Magpie magazine, in fact, another great magazine. So yeah, I mean, how long have we got left there, Alan? We're about at the hour, aren't we?
Yeah, you have 3 minutes left.
3 minutes. Has anybody played with the new Raspberry Pi Pico yet?
No.
I know you've got one as well, Cliff, so that makes it even worse.
I know, just having time having time. Yeah.
Yeah, flying, I suppose, takes some of the time out of that.
And prepping,
Uh,
I've got a talk as well in an hour and a bit. So just make
This is
sure
true.
my slides are up to date.
Yep, that's well worth checking out. I've seen Cliff's talk. And by all means, Cliff, tell people what it is you're going to talk about.
I'm going to
It's
talk
awesome.
about using IoT to build a flight simulator, and how we went about it and what it does and how it works. So as well as teaching you a little bit about aviation and how we fly approaches to land at foggy airports. So if you're scared of it, if you're scared of flying, come along. If you're not scared of flying, come along anyway.
I think there's even a tear-jerking moment in it, isn't there? I think I had a tear in my eye at one point. So
Yeah, a lot of people have said that, but yeah,
Yeah.
I think I'm yeah.
Most of your talks seem to be like that. It's definitely a feel-good factor. Awesome. Well worth checking out on that respect. And again, just call out to the number of times that I give talks and then people will send me DMs on Twitter or something where they've started to play with it, and it really does make me feel awesome. So even if you think it's silly, and I hope you don't, then just tag me in a tweet and you'll make my day, because I love seeing people picking this sort of stuff up once they've seen these sorts of talks. Because it's awesome and it's great, and it's not only just for kids, this sort of stuff. Adults get quite a lot of a boon out of this. Certainly if you're a techie and a geek like I am, then it's well worth doing. But I really appreciate you coming along to my talk. It's my first NBC talk, so I hope, other than that issue with it building there at the end, that everything went okay and you got everything you needed out of it. And hopefully we'll see you all again soon. So yeah, thank you.